All right, strap yourselves in because today we are going deep, really deep, like
Yeah.
into the fabric of reality itself, deep. I'm talking piles of books and research, articles, physics, philosophy, even some computer science and evolutionary theory.
Mm.
Ambitious? Maybe. But thankfully, I'm not alone on this one. I've got an expert guide with me, ready to help us make sense of it all.
And what's so exciting about this particular deep dive is we'll see how all these different fields actually connect. They offer different pieces of the same puzzle, a puzzle that helps us understand not just what reality is, but how we can even begin to grasp it.
I like that. A puzzle of reality.
It reminds me of when I was a kid. I thought understanding the universe was all about memorizing every single fact, like every fact in every encyclopedia.
Right.
But as I got older, I started to realize it was less about the facts themselves and more about how they connect. It's about finding those explanations that unlock deeper truths. Kind of like, figuring out why planets move in these predictable orbits instead of just charting their positions. Absolutely. It's the difference between knowing that something happens and understanding why it happens. We can observe that objects fall to the ground, but it's the theory of gravity that gives us a deeper understanding of the forces at play.
It's not like going beyond just the what and into the why.
Exactly. And that's what we're aiming for today, to build mental models that let us grasp the why behind the what of reality.
So less trivia, more aha moments, right?
Precisely. And things get even wilder when we start exploring things like virtual reality. And I'm not just talking about VR headsets we use for gaming. I mean, we're going to go deep into the possibility that the multiverse itself could contain objects that can perfectly mimic any other part of reality.
Okay, now you've got me hooked. So it's not just about us creating simulations, but that the universe itself might be capable of generating these really detailed representations of anything within it.
Exactly. Think of flight simulators. They mimic the experience of flying without actually taking you off the ground. So if we can simulate something as complex as flying, could a sufficiently advanced computer simulate anything? And that's the essence of what's called the Turing Principle. This idea that a universal computer, given the right program, could simulate any physically possible environment.
Hold on, are you saying there could be like a perfect simulation of our entire reality out there? I mean, that's unsettling, but also kind of awesome. And this Turing principle, does it suggest that the universe's ability to, I guess, represent itself is somehow essential to how we understand it?
That's a great question. And it leads us to another fascinating concept, the multiverse. Okay, picture this. You're walking along, and instead of casting just one shadow, you cast multiple shadows, each one representing a different path your life could have taken.
Okay.
That's kind of a visual analogy for the multiverse. But instead of shadows, we're talking about quantum interference.
Okay, I see where you're going with this. But quantum interference sounds pretty complex. I mean, can you break that down for our listener a little bit? Like, what does that even mean?
Of course. Let's think about photons, those tiny particles of light. In experiments, they do this really strange thing called quantum interference. They act like waves, spreading out, traveling through multiple paths at the same time. And here's where it gets really weird. Even the paths not taken by a photon can still influence the outcome of the experiment.
So it's like the universe is kind of exploring all these different possibilities all at once, even though we only experience one outcome.
Exactly. By embracing this idea of a multiverse where all these potential realities exist simultaneously, the, I guess, bizarre behavior of these photons, it starts to make a lot more sense. It suggests that reality is far richer and more complex than we think, and it opens up some seriously mind-bending possibilities, like time travel.
Time travel, now that's a topic that always gets people talking. But can we really change the past? What about those paradoxes? Like, meeting your past self and then accidentally preventing your own birth. Wouldn't that just break everything?
Those paradoxes are definitely intriguing. But it's important to remember that what we think of as a paradox might actually be more about the difficulty of, coding time travel simulations. Imagine stepping into a time machine and then meeting your future self. They remember the encounter vividly while you haven't experienced it yet. It really comes down to understanding how those experiences can loop back on themselves and create this seemingly seamless story, even within a simulated time loop.
So just because it's really hard to code time travel simulations doesn't mean it's impossible in reality, right?
Exactly. And here's another way to think about it. When you meet your future self, they've lived through different things, made different choices. This suggests that we're not traveling along a single fixed timeline, but rather navigating a multiverse of possibilities, where choices determine which path we actually experience.
Okay, my brain is officially melting. We've gone from like the nature of understanding to virtual reality, the multiverse, now time travel. It's amazing how it all fits together. But I'm curious, where does life itself fit into all of this? I mean, we've been talking about the vastness of the universe, but
Yeah.
where did WE fit in?
That is a profound question, and it's one that has puzzled philosophers and scientists forever, really. Stephen Hawking, he once called humans chemical scum.
Oh, wow.
It sounds harsh, but he was really just highlighting how insignificant life might seem from a purely physical perspective.
Yeah, I mean, I guess that does make sense, even coming from someone brilliant like Stephen Hawking.
Hmm.
But I have a feeling you might have a slightly more uplifting perspective, right?
Absolutely. Here's the thing. Life, despite how fragile it seems, embodies something truly extraordinary: knowledge. Genes, for example, contain information honed over billions of years of evolution. It allows life to adapt and thrive in so many different environments. It's not just about existing, it's about knowing how to exist, how to survive, how to flourish.
So it's less about the raw materials of life and more about the information encoded within those materials. That's what
Yeah.
makes it so special.
Exactly. You could even imagine hypothetical life forms that don't replicate in the traditional sense, like genes encoded within a diamond. As long as they possess knowledge that helps them survive, they embody this crucial aspect of life, this ability to harness information to, navigate reality.
Gaiman encoded genes. Wow.
Hmm.
But I'm starting to see how this all ties back to what we were talking about before. If knowledge is so central to life, and the universe itself seems capable of generating and processing information through these simulations, is there a deeper connection there?
You're spot on. It leads us to a key takeaway. Knowledge creation, whether through biological evolution or human ingenuity, is fundamental. It creates structure, makes different parallel universes more alike as they learn and adapt. Almost like knowledge is this unifying force across multiverse.
Okay, that one's going to take a minute to sink in. We've covered a lot of ground. The quest for understanding, the mind-blowing Turing Principle, the multiverse, now the importance of knowledge creation. But what does all of this mean for, things like free will, purpose, morality? Do those things even matter in a reality as vast and complex as the one we're describing?
These are such important questions, and ones that we're going to delve into much deeper as we continue our deep dive. But I can say that this view of reality, this unified view, it doesn't diminish the importance of those concepts at all. In fact, it offers a really empowering and optimistic perspective on the role of free will, purpose, and morality. But we'll save those fascinating discussions for part 2 of our exploration. Welcome back to our deep dive into the fabric of reality. Before we jump ahead, let's just take a second to recap where we left off. We've been talking about some pretty mind-bending concepts, haven't we? The quest for a deeper understanding, then the implications of that wild Turing principle, the multiverse, the whole idea of it, and then the essential role knowledge creation plays in, well, shaping reality.
It's been a wild ride so far, that's for sure. And last time, we ended by touching on some really big questions, free will, purpose, morality. Those concepts that can feel a bit, shaky when you start thinking about just how vast and complex the universe really is.
Exactly. And before we dive into those deep philosophical waters, I want to introduce you to a pretty fascinating tool, one with the potential to, I'd say, revolutionize how we understand reality: the quantum computer.
Quantum computers, okay. They sound like something straight out of science fiction. Can you explain to our listener, in simple terms, what makes them so different from the computers we use every day?
Absolutely. At their core, all computers, they rely on manipulating information, right? The computers we're all familiar with use bits, which can be either a 0 or a 1. Think of it like flipping a coin. It can land on heads or tails, but not both at the same time.
Gotcha.
Quantum computers, though, they use something called qubits. And these qubits, they can exist in a superposition, meaning they can represent both 0 and 1 simultaneously.
So instead of a coin landing on heads or tails, a qubit is like, a spinning coin that's both heads and tails at the same time. That's pretty wild.
It is, and that's a great analogy. And it's this ability to exist in multiple states at once that gives quantum computers their power. They can perform certain types of calculations way faster than classical computers, exponentially faster, really, like factoring large numbers, for instance. That's a task that would take a regular computer, I don't know, billions of years maybe, but a quantum computer could do it in a fraction of the time.
Okay, I see why people are saying quantum computers are such a game changer. But how do they relate to, the bigger picture we've been talking about? Multiverses and time travel and all that. Where do quantum computers fit in?
That's where it gets really fascinating. Remember when we were talking about the multiverse and that strange behavior of photons, how they exhibit quantum interference? Well, quantum computers are really good at simulating quantum phenomena. A classical computer would struggle to represent all those possible paths a photon could take, but a quantum computer can capture all those possibilities at the same time, mimicking that essence of quantum interference.
So are you saying quantum computers are giving us a window into the multiverse?
In a way, yes. But remember, we also talked about how simulating the entire multiverse, that would be incredibly difficult, even for a quantum computer.
Right, right.
But here's the key takeaway. While we might not be able to simulate the entire multiverse, a quantum computer can efficiently render any physically possible quantum environment. So, we can still explore and test these quantum theories in ways that just weren't possible before.
So it's kind of like having a super powerful telescope, letting us zoom in on certain parts of the multiverse, even if we can't see the whole thing all at once.
Exactly. And remember that Turing Principle we discussed earlier. The idea that a universal computer could simulate any physically possible environment. Well, quantum computers, they take that principle and extend it into the realm of quantum phenomena, allowing us to delve into, well, how reality operates at its most fundamental level.
That's pretty amazing.
Yeah.
It feels like we're right on the edge of uncovering some really profound secrets about the universe. But before we get too carried away with the possibilities of quantum computers, I want to go back to something else you mentioned that I'm really curious about. The omega point.
Ah, yes, the omega point. It's a very speculative idea, but it does connect a lot of the things we've been discussing. It essentially takes that Turing principle we talked about and pushes it to its ultimate conclusion, thinking about the fate of the entire universe. Imagine a future where intelligence keeps evolving, where we're creating these super powerful computers, maybe even quantum computers that are beyond anything we can imagine right now. And theoretically, these computers, they could harness the energy of, well, the collapsing universe to do a mind-boggling amount of computation.
Wait, hold on. Infinite computation. Doesn't that, violate the laws of physics? Isn't there a limit to how much energy and information can exist in the universe?
It's definitely pushing the boundaries of our current understanding, that's for sure. But the key is recognizing that the end of the universe, as we think of it, might not be a sudden stop. It could be more like a transition into a different state. Like, think about how water changes from liquid to ice. It's still water, but it's in a completely different form.
Okay, yeah.
Similarly, the end of the universe, it could be a transformation into a state governed by different laws of physics, laws that could accommodate this idea of infinite computation.
I see. So instead of everything just fading to black, it's more like the universe transforming into this cosmic computer, capable of processing an infinite amount of information.
That's a simplified way to think about it, but you're getting the idea. The omega point theory suggests that the ultimate fate of the universe could be this state of maximum knowledge, maximum complexity, where the very fabric of reality itself becomes this kind of substrate for computation. And here's where it gets really wild. This intelligence, it wouldn't just be passively observing reality, it would be actively shaping it, maybe even influencing the very laws of physics that govern its existence.
Whoa, that's a lot to take in. A universe-scale intelligence that shapes reality. It's both incredibly awesome and a little bit terrifying, to be honest. But let's be real here. Is this omega point even possible, or is it just some thought experiment for theoretical physicists?
It's a great question. It's important to say that the omega point is very, very speculative. There are lots of questions about whether it's even physically possible. But it does raise some really deep questions about the nature of reality, the limits of computation, and the potential for intelligence to shape the universe in these grand, incredible ways.
It definitely does. And I think it ties back beautifully to what we were talking about before, about how important knowledge creation is. It's almost like the omega point represents the ultimate goal of that process, a state where knowledge and intelligence become the main forces shaping reality itself.
Exactly. And that leads us to think about the deeper implications of all of this for us, for humans.
Yeah.
If we're, in a sense, participants in this grand cosmic drama of knowledge creation, what does that say about free will, purpose, and the meaning of our lives? Especially within a reality as vast and complex as the one we've been exploring.
Those are the million-dollar questions. And I'm really interested to hear your thoughts on how this unified view of reality, this view we've been discussing, how it might offer a new perspective on these big philosophical questions that have been around forever. But before we go there, let's just take a moment to let all of this information sink in.
A moment of reflection is always a good thing when you're exploring the edges of knowledge. Absolutely. Join us in part 3, where we'll tackle those big questions head on and really dig into what it means to be human in a universe that's full of, well, infinite possibilities.
All right, we're back for the final part of our deep dive into the fabric of reality. It's been quite a journey. The Turing Principle, the multiverse, those powerful quantum computers, even that mind-bending omega point idea. But now I want to bring it all back to us. We've been dancing around these big questions about free will, purpose, morality, and I'm really curious to hear how this unified view of reality, the one we've been exploring, how it might shed some light on these age-old philosophical dilemmas.
It's a perfect way to wrap things up because, as you said, it really all comes back to what it means to be human in a universe that's way more vast and complex than we ever imagined. Let's start with free will. It's often said that if the universe works according to these fixed laws of physics, then our choices, they're already predetermined. Free will is just an illusion. But this multiverse model, it offers a really different perspective.
Okay, I'm listening. How does the multiverse change how we think about free will?
Well, the multiverse suggests that every possible choice, every path you could possibly take, it actually exists in some parallel universe. So when you make a decision, you're not just following a predetermined path, you're actually choosing which of these infinite possibilities you're going to experience. Your choice literally shapes which branch of the multiverse you inhabit.
So it's like we're constantly navigating this choose-your-own-adventure universe where our choices actually create the reality we experience.
Exactly. And that brings us to the question of purpose. Now, you might think, well, if there are infinite versions of me out there living out every possible scenario, does anything I do even matter? But I'd say it matters a lot. Remember how we talked about knowledge creation being this fundamental force shaping the multiverse? Every discovery, every creative act, every single decision you make, it adds to that tapestry of reality.
So even our small individual choices, they can ripple out across the multiverse. It's not just about making groundbreaking discoveries. It's about every act of kindness, every piece of art we create, every connection we make with another person. Those things all contribute to the bigger picture.
Exactly. It's about recognizing that our lives, even though they feel fleeting, are interwoven with the fabric of reality itself. Purpose doesn't come from some external source. It comes from engaging with the world, striving to understand it, creating beauty and meaning, and ultimately shaping our own reality through the choices we make.
I really love that perspective. It's so much more expansive and hopeful than this idea that we're just tiny, insignificant specks in a meaningless void.
Absolutely. And it brings us to the idea of morality. In this unified view of reality, morality isn't about following a set of rules given to us by some higher authority. It's about recognizing that our actions have consequences, not just within our own little bubble of experience, but potentially across the vast multiverse. True understanding means being open to different viewpoints, admitting that we can be wrong, and always trying to improve our knowledge and our choices.
It's like this cosmic responsibility then, knowing that our choices have these far-reaching implications. It really makes you think about the impact of your actions, not just on yourself or the people around you, but on the bigger picture, the fabric of reality itself.
Exactly. And that sense of responsibility, that understanding of how interconnected we all are, I think that's at the heart of living a truly meaningful and ethical life. This unified view of reality that we've been exploring, it doesn't make humans less important. It actually makes us more important. It puts us right at the center of this dynamic, ever-changing universe where our choices, our creativity, our pursuit of knowledge, they all play a vital role in shaping reality itself.
This has been an amazing journey. We started with a pile of books and research, and we've ended up with a whole new way of looking at the universe and our place in it. It's both humbling and empowering to realize that we actually have a part to play in this grand cosmic story.
It really is. And it highlights why it's so important to be curious, to think critically, and to be willing to question what we think we know. This quest to understand the fabric of reality has just begun. And the deeper we dive, the more we realize how much more there is to discover.
And on that inspiring note, I think it's time to wrap up our deep dive. But before we go, I want to leave our listeners with one final thought to ponder. We've talked about this vast multiverse, the power of knowledge, the importance of our choices. But what if the very act of exploring these ideas, of joining us on this deep dive, is itself a form of knowledge creation? What if, by expanding our understanding of reality, we're actually contributing to its richness and complexity?
That's a wonderful and thought-provoking question to leave our listeners with. It suggests that the search for knowledge isn't just a passive thing, it's an active participation in the unfolding story of the universe. The more we try to understand the universe, the more understandable it becomes, and the more we see the incredible interconnectedness of everything.
So keep asking those questions, keep exploring, keep diving deep. The fabric of reality is waiting to be unraveled, and who knows what amazing things you might find along the way. Thanks for joining us on this incredible journey, and until next time, keep searching for those aha moments that reveal the hidden patterns and connections that make up this universe we call home.